right, I'm going to start lecturing. I'm going to lecture today on chapter 14. We're going to do this a little different. Normally we've been building a program first. I'm going to give you the hard copy of the source code. This is just so different when you start working with applets that I decided to do the do the lecture part first. Whether that's right or wrong, we'll see. So again, this is the last chapter in this book that we'll cover. Okay, so I'm not going to cover the thing on recursion, and I'm not going to cover the database stuff in here. So we're going to cover this. What we don't finish today, we'll finish Monday, which probably won't take the whole period. And then you're going to have all of next week for lab, and we'll see where we are then. All right? But either the week after that or else the week after that, we're going to start on the Android stuff. Okay? All right. So if you're following along in your book, I have no idea what page we're on, but looks like 911. All right? Applets and more. So you can see the different topics. I'm not going to read them to you. All right? I'm going to skip like the brief introduction to HTML. I'm not going over that at all. And I also will tell you, you may or may not have noticed this the other day, but when I ran this thing, when I ran this program for you, I'll let that start up. Crud, that didn't look good. Yeah, okay. When I ran this program for you the other day, you may or may not have noticed this, but if I bring it up here, you're going to get a hard copy of this in a bit. But when I bring up the thermometer.java program and I come up and run it, come on, you may or may not have noticed that what came up here was this little thing here, and it looks kind of like it's the wrong shape, etc. All right, so I can stretch it out and make it bigger. But what I'm trying to get across to you is if you look at the title bar on there, this is something that's called Applet Viewer. Now back in the day, so we're talking probably a good 20 years ago, back in the day, a lot of people when they were working on their Java programs, they didn't have an internet connection. So what Applet Viewer does is it basically, this is not running on the internet here, all right? But it's built into Java itself. You literally can go in, and I've been trying to do it, and I've had just limited success. Notice I've got a file here that's called thermometer.html. All right, and I tried to run it from there, but it didn't like it. All right, there was some HTML in this file, but it just didn't like that. So I just ran it right here, right from the Applet Viewer. All right, the bottom line is once you're working on yours and you're doing the house one, which is the other one, again, here's, like I told you, there's my house one. When I go in and run it, the same thing happens. All right, so I can run it right from the Applet Viewer. It's not a problem doing that. Is that the best way of doing it? It is a way of doing it. So everything that we've done thus far up till this point, everything in this book other than this chapter talks about one of the two types of ways that you can create Java. With Java, you can write an application or you can write an applet. Everything in 15 out of these 16 chapters is on applications. So what's different with applets? One first big thing, there's no main. Okay? And as it says, it's a program designed or associated with a web page. It's supposed to be executed as part of a web page. There's a lot of Java that's out there, not just JavaScript, but there's a lot of Java that's out there on the web where people have created games and the like, and they've done it via applets. All right? I've got, what I'll do during the break, I got to remember to do this, is go upstairs and on the external hard drive that I have, geez, I sat down one day and I was looking at this book and it was like how to make some quick, simple Java applets. Well, they showed you one and then they asked you to make like about 20 or 30 more. So I made all of them. You know, I didn't take them from a book. They weren't in the book. They just showed you how to make the first one. But I've got that upstairs and most of them are really kind of hokey. But if I can find that during the break, I'll put that out there, and you can take a look at it if you want. All right, so again, the difference, an application, as mentioned, is a standalone program that runs on the computer. Applets are Java programs that are usually part of a website. Applets are important, as it says, because they can be used to extend the capabilities of a web page. In fact, Java has more than just applets that you can create. Just like there's ASP, and if you don't know this by now, ASP is active server pages, which is, Microsoft's way of creating interactive web pages. Java has JSP, which is Java server pages, and you can use those also. They're very similar in a lot of ways. All right, and it used to be years ago that instead of giving you a class in jQuery, that class, the Ajax and JavaScript website development, what I taught in there was JSP. But talking to a lot of people out in the community, there was no one around here that was demanding that. And a lot of people wanted to get some training in jQuery, and that's one of the reasons that I went with jQuery and changed it around. All right. So they give an example here, and this is a dumb example, just for one reason. The actual applet is this little gray area that you see right there. That's the applet. The rest of the stuff that you see here, all this, that's just HTML. So you can literally write HTML, and I'm going to show you that a little bit later today, and you can basically add your Java to it. And I'll show you how to do that in just a bit. All right. So some of the things, as it says, there's some of the restrictions on applets. I'm not going to read that to you. You can see the bulletized list. When Java was first created, all right, when Java was first created, Java had all sorts of security holes, if you didn't ever hear about this. And one of the security holes was if you didn't know what you were doing with Java, or you really did know, you could write not only to your hard drive, but you could write to other people's hard drives. You could read from other people's hard drives. You could do a lot of stuff you really shouldn't be allowed to do with the programming language. So Java changed the way that their architecture, and they basically said what you're in right now is you're in a sandbox. So imagine you're a little kid, and you're at a playground, and there's 10 of you, and you each have your own sandbox. And the idea is you can't even take your sand out of there and throw it at somebody else or put it in another sandbox. So the only damage you can do is in your sandbox. Does that make sense? In much the same way with Java, be it with applets or with applications, they tried setting it up so that the worst thing you could do would be to hose yourself. Maybe lock up your own machine, remove something from your hard drive that you didn't mean to, write something to your hard drive that you didn't mean to, etc. But that was about the worst thing you could do. And then people started to complain. And they started to complain because they said that Java went from one extreme to the other. They went from allowing everything to almost allowing nothing. So one of the things that came up as a part of this was now there is something, and it's been around for years, but now there's something that's called trusted applets. And with trusted applets, what I can do is I can create an applet, and I can create a group of people that applet can affect. And I can possibly, at least, let you do some of these operations that you see up there that say applets can't do this. But it has to be agreed to. Typically, even if Mark's in my group, I'm not going to be able to write to his hard drive or read from his hard drive. All right, but there are trusted applets that give you a little bit more leeway than a, quote, regular applet, unquote, does. But regular applets, again, you can read the stuff that's here. All right? And for lack of better words, it was set up like that to protect you from yourself. All right, this is a primer on HTML. Not going to go over a bit of it. This is an H1 tag, etc. This is how you make a line break. Scintillating reading, but I'm not going to read any of it anyway. This is how you put in an anchor tag. All right, so I'm moving up all the way here to page 922 on the bottom of the page. Creating applets from Swing. All right, as it says there, you extend a class from JApplet to create an applet. So virtually everything that you do with applets, you will be extending JApplet. All right, there is a regular applet class that isn't part of Swing. It's part of the AWT. But virtually everything that you see is going to be done like this. So as it says, by now you know almost everything that's necessary to create an applet. Again, there'll be some different methods that we call, but the actual writing of the Java code, there's probably not too much in there that you don't already know, is what I think the author's saying. All right, you can think of an applet as a GUI application that runs under the control of a web browser. Instead of displaying its own window, it appears in the browser's window. So some of the differences are shown here, and it's worth going over these. All right, again, a Java app, the stuff we did in the last chapter, The stuff from chapter 11, your last assignment, where you were either supposed to do the Joes in GUI, or you were supposed to do the program you've been working on with the production worker and all the other stuff in GUI. All of those, as it says, those GUIs, straight GUI applications, all right, they inherit from JFrame. Applets inherit from JApplet. All right, notice it's part of the javax.swing package, so you just keep importing the same thing you've been importing anyway. Second, a GUI app has a constructor that creates components. An applet doesn't normally have a constructor. All right, rather applets have a method that's called init. Now, it is possible to write yourself an applet that has no init in it whatsoever. I don't remember ever seeing it done. But there are going to be other methods that are in here, like a start method, a stop method, a pause method, etc., that are basically just associated with applets. All right, and you'll see that as we go on in here. All right, notice, you can read them, but the following methods commonly used in GUI apps are not called in an applet, so all that stuff goes away. And again, there's no main method. That's sort of a lie. And just so you know this, it's possible for you to go and create an applet, okay? And you can create an applet, and at the bottom of it, you can put in a main. Why would you do that? Because then you can run it as either an applet or as an application. So it is possible to write a Java program that you can run either as an applet or as an application. I'm not sure why you would want to do that, other than maybe for demonstrating purposes. But I didn't even know you could do this until a few years ago. And somehow one day I was reading an article, and they had a link to it that said, run your Java applet as an application. Well, that looks interesting. So I clicked it and read the thing. All right. I didn't save it. I wish I would have. But I'm sure that if you go and you Google it, that you can find some information on it. All right. So first thing they're going to run here is a simple applet. It's not going to do very much, but I think the author just shows you this here so you can start seeing some of the stuff. All right, notice, again, javax swing, java.awt.star, so like we did before. Again, extending JApplet. And as mentioned, this is going to take the place of a main method and a init method. Or I should say this is going to take the place of a constructor. But like a constructor, like a NOAR constructor, typically this has no parameters attached with it. All right. This particular example, literally it'll put a label on the screen that says, this is my very first applet. I mean, we could run that, I guess, and we could put it over, etc., but it's not going to really do very much. All right. So let's look at how you would run this. In fact, what I'm going to do is, rather than this, I'm going to show you the one that I had for the one that I have in here for the thermometer. Okay. Okay. The only thing that's actually required to run an applet is that. You don't need any of the rest of that information that's shown there. Did you all hear that? The only thing you need are the two lines that are in gray. The other stuff, we can come in here and put an HTML header in, put a head section in with a title, we can put a body in here, etc. And I notice, I guess I've got a beginning paragraph tag and there's no ending paragraph tag. There should actually be one, because you want to be a good little programmer. But the idea is you can go and just put in this. So let's take a quick look at just that. All right. And I'm going to tell you what, I'm going to move it down so I can make this a lot bigger. So again, this is all you actually need. This is the applet tag right here. That's the beginning, of course. That's the ending. The width and the height are how big you want your window to be. The reason that when I ran that example, when I ran both the thermometer and the house examples, they look funky, is that the applet viewer, that extra program that Java provides, has its own width and height already set in the applet viewer. So you can stretch it and make it bigger or smaller, all right, but it has a standard size. What this is, this should look familiar to you. That's the name of your compiled program, right? All right. and it's the .class file. So you got to say applet code equals this, and then whatever width you want it to be on the screen, whatever height you want it to be on the screen, you close that opening tag, and you put in a closing tag. That's if you decide you want to try to run it. We had all sorts of problems last year running stuff from Eclipse. All right, and I followed some of the stuff that was in their documentation, and it just didn't work. I tried some stuff at home, and it worked fine. Brought it back here, tried it, and it didn't work. So we've just been running it off of the applet viewer. All right. So what they show you in the book is pretty much the same thing then, right here. And it's just these two lines, as I mentioned, are the only two that you need. All right. And when you put in those, all right, if we do this, a simple applet, etc., this is that first program that they show. It's a label that says this is my very first applet. Not really a whole heck of a lot in there. Then they talk about applet viewer. You can actually run applet viewer from the command line. They show you how to do that in here. I'm not going to do that because there's absolutely no reason for us to run something from the command line. All right. So let's jump up here to page 926. And again, here the author is talking about handling events in an applet. I'm trying to keep up with in the book here too, so give me just a second to catch back up. All right. So as it says in an applet, events are handled with event listeners exactly as they are in GUI apps. What does that mean? That means in English that if you're going to add GUI elements, buttons and whatever, you'll handle them the same way. All right. You'll implement action listener, you'll have an action performed event. If it's a radio button or a regular button. If it's a drop down, you'll have the item listener and the whatever it was, the item changed. All right, so it's the same stuff we talked about in previous chapters. So let's look at what's new here. This is a temperature conversion program right here in 14.8, and they do run it. It's going to be up a few pages, but I just want you to see this, and then we'll back up and look at it. So that's what it looks like. Again, this is the same one I showed you at the beginning of the chapter, but just so you know, again, this section right here that you see in the bottom left-hand corner, that's the applet. Everything else that you see in here, that's an H1 header. That's a paragraph. That's just text. That's a paragraph. So the actual applet is everything I'm drawing the box around here. All right? So let's take a quick look at it. Again, public class temp converter extends JApplet. You already seen that. Okay? We could literally create this same program. Instead of having extend applet rather, we could have extends JFrame. Then instead of having an init in there like that, we could have a main. And if we did that, we could make this into an application. And if we did and made it into an application, whoops, it would look just like this with just the gray stuff in there. So we could do that. In fact, we did that in the last chapter, not with a temperature conversion, but you might remember that we looked at the thing that had kilometers to miles and all that other stuff. You could go back and take those kilometer to miles in any of those programs and redo them. Instead of having them be an application, you could have them be an applet. Again, remove the main, replace it with an init. All right, and instead of extending JFrame, extend JApplet. Other than that, there aren't too many changes that you have to make. So this is very similar, almost identical to the program that we looked at in the last chapter. So I'm not going to go over it. There's your HTML file. But as I told you before, the only stuff, so look at how long this thing is. It's half of that page and part of this page. But as I mentioned, the only thing that you need is this. All right? All right. Using AWT for portability. So again, if you're following along, page 931 in the book. It says their applets that use Swing components may be incompatible with some browsers. That's old. There shouldn't be any compatibility problem anymore unless you're using a very old browser. But if you're using one of the newer versions of Chrome or Safari or IE or Firefox or Opera, all right, those are probably the big five. If you're using any of those, you should have no compatibility problems. So, but they say that if you do, so if you're running it with an old browser or whatever, use AWT components instead of swing. So again, rather than extending extending J applet, you'll extend applet. Rather than having a J label, you'll have a label. A J button, you'll have a button, etc. And that's what they're talking about here. All right. So again, notice you can see the chart here on the bottom of page 931. Again, the swing classes were intentionally designed with constructors and methods similar to their AWT counterparts. Okay? So they go back and they rewrite the same program that they just did. They go back and they rewrite it, but they rewrite it as an abstract window toolkit, and you'll see when you get done, they run it, and it really doesn't look very different. All right? So again, when you talk here, it says, here's the modifications that they made. Not very many. J applet to applet, J panel to panel, J label to label, J text field to text field, J button to button. All right? And that import java x.swing.star was removed. You could leave it there, but it's not being used by anything. All right? But other than that, that's the only changes. So you can write a program as either a swing applet or a non-swing applet and change it from one to the other simply by doing this. I don't see where there's ever going to be an advantage to not making it a swing. All right, again, that's me speaking, so you might find books that disagree with that, but I don't see why you would do it. All right, jumping up to page 936. Now, this is either going to be something you're really going to like, or you're going to think really, really, really stinks. So you've been warned in advance. All right, you can use Java to draw shapes. You probably are aware of this, but where is the 0, 0 coordinate on my screen? Top left-hand corner. That's the key thing to keep in mind. All right. You can use Java to draw lines. You can use it to draw ellipses, which become circles, rectangles, which can become squares, and polygons, which you can make look like anything basically you want. They've got an example in here where they draw a stop sign. All right. But those are your major shapes. And when you create things like rectangles, you've got your choice. You can create a rectangle that's either solid but has nothing inside of it. In other words, it's just got the border and the inside's white or clear or whatever. Or you can make it a filled rectangle. Okay? So again, in the example that I showed you before, wherever the heck that is, I don't want to do that. I'm going to get an error message again, but that's fine. Yeah. If you look in here, that's just a filled rectangle. That's a filled rectangle. And that's a filled rectangle. All right? And you say, well, yeah, those are unfilled rectangles. Right here, this is right there. That is a rectangle with a line drawn there and a line drawn there. Rectangle with a line drawn there and a line drawn there. Rectangle with a line here and a line here. And then finally, rectangle with a little circle put in there. Does that make sense? Because that's how I want you to create yours. If you can go as nuts as you want to go with this. All right, and I think I showed you this a while back. I'd have to dig it out, but one of my students did this and actually grabbed a thing from Architectural Digest and made thing. He put a deck on it and all sorts of stuff. I would never expect you to do something like that. And then when I asked him, I said, can I have your code? And he goes, no, you can have my class file so you can run it and show people, but you sure as hell can't have my code. I said, why not? He said, I spent 2 days on this, did nothing else because I thought it was cool. I understood that, not a problem. All right, so that's the XY coordinate system again, 0, 0. So if you've got a 300 by 200 pixel window, the very bottom corner here, as it says, will be 299, 199. Does that make sense? And with your X's, you're moving from left to right. With your Y's, you're moving down. Does all that make sense? Because it pretty much follows the XY axis that you learned back in high school algebra. All right. So here's some of the graphic objects and some of the stuff that you can do here shown on page 937. Set color, get color, draw line, draw rect, when you do a draw rect or you do a draw oval, all right, notice you don't get the filled in one. It's fill rec and fill oval that get where they're actually, you know, filled in. Okay. But I'm not going to run through these. You can read those yourselves. And they've got a lot of programs here. Again, you can work with arcs, you can work with polygons, etc. All right. And there's a lot of different stuff that you can do. Hopefully you all remember this, and I can go back and show you, but I mean, like I said, hopefully you all remember this, that back on the P drive for this class, you've got all the source code for this book. And in this book, they've got several programs in here, in this chapter, where, for instance, we're going to get there in just a minute, but code listing 11, they just draw lines. They literally draw an X, so you can see how that's done. All right, but before we go through that, let's take a look at a little bit of text as they show it here. It says, in order to call any of these methods, you must get a reference to the component's graphics object. So you're going to have something like this in any program, in any applet where you're doing drawing. All right, G, you don't have to call it G, but most people do. It's G for graphics. All right, and I may have gone over it, but do you notice, just to show you this real quick, draw line, draw rect, draw oval, draw arc, draw polygon, and that one does kind of what you think it would do. If you want to draw text in your applet, you don't have to do it for your assignment, but if you did, you use draw string. All right. Now, kind of a weird thing, just so you know this, that's a method that you can put in your program, but you can't call that method. In other words, you in code cannot call paint. The browser calls paint on an as-needed basis. All right. What you can call, if you need to, you don't see it in there very often, but what you can call is repaint. And what repaint does is repaint goes and calls paint rather, kind of kicks it in the butt and says, hey. But as far as calling of paint, you put the code in the paint method, but the actual method itself is called by the browser or at the applet viewer. All right. So as it says, the paint method is responsible for displaying or painting a component on screen. This method is automatically called when the component is first displayed and called again anytime it needs to be redisplayed or rewritten. All right. So again, going back to our example, when does that happen? Well, think about it. All right. That has to be redrawn, just that part. So does that. So does that, and that, and that, and that. Once I've drawn this, there's never a reason to redraw my roof and the house except for the windows and the door. All right. Says, notice that the method's argument is a graphics object, and you see that here. When this method is called for a component, the graphics object that belongs to the component is automatically passed as an argument. By you overriding the paint method, you can have paint do what you want it to do. And we're going to look at that under the guise of that thermometer app in just a minute. Okay. So again, this first example here, here's paint. So notice what we do first. We super dot paint, so we're basically right there, we're calling the parent paint method. Normally it doesn't do anything, but it's a good idea to call that anyway. Well, notice, because the key thing here is to just read the comments. We're going to set our color to red. All right, then we're going to draw a line that starts at position 2020 and ends at position 280. Then we draw another one. Now we're setting the color to blue, and instead of going from 2020 to 280, we go from 280 to 2280. So in other words, our red line was like this, and our blue line will be like this. Does that make sense? And that's all the program does. And again, you've got this program already. As I mentioned, all the code from the book is out there already. And the reason that that's important, I just want to mention this to you. I said this to you a couple weeks ago, but I'm saying it again now. What I don't want you to do, because I've had people do this in the past, they have problems. So literally, they draw a line for this, a line for this, a line for this, then 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 a line, then a line, then a line, then a line, then a line. You get the idea? I don't want you to do that. I don't know how many lines that would be, probably somewhere around 20. And I've seen people do this. I've written that program like this. And what happens is, instead of having the nice little house, that looks the way it does right now, when you start drawing it as lines, what you get is you get a line over here, and then this one, instead of, that's this line. Instead of this one, now it's over here someplace. Then you got another line over here, and another line here, and another line here, and another line there. Then you've got to connect the lines. That's ridiculous. All right? And I don't want you to do that. I'm not going to accept a program that's like that. Okay? So in the next example, they come in here, and now notice what they're doing. They're setting the color to black, and they're drawing a rectangle. All right? And that rectangle won't be filled. And then they're drawing another rectangle. This one is filled. So you can see the difference between them. And these other coordinates here, again, are where you want the rectangle to start and end. All that stuff is mentioned earlier, but I didn't go over what those coordinates are, but they're all explained in the book. Right? Well, is a rectangle a square, or is a square a rectangle? Really, a square is a rectangle. All right, it's just a rectangle that has the same length and the same width. Then they do the same thing with ovals. And just so you know, it's called an oval. Technically, it's an ellipse, or an ellipsis, whatever, ellipse, I guess. But again, when you do this, there really isn't a circle. There's an ellipse, all right, or an oval that you work with. Okay? So again, with the example that they have right here, notice it says they come through here, and first they draw a black unfilled oval, then they draw a green filled oval. And again, you can see the difference. All right. As it says, to draw a circle, simply draw an oval with an enclosing rectangle that is a square. In other words, the enclosing square's width and height should be the same. Okay? And there's tons of examples out there on how to do that. When you work with arcs, that's when you can start making a little, I don't know if you'd call them cooler drawings or not, but you can see what's in there. So again, what the author builds toward in here is, he says, let's make a stop sign. All right, and that's actually on the next page here. So if you take a look, that's what he wants to do. So, it takes a little bit of planning, as you might guess, to do that. All right, and make it look the way that you want it to look. So he creates this polygon demo, and he makes the color red, and when you get done, you've got a stop sign. Then he comes in and he uses the drawstring method to draw the word stop on the stop sign. Okay? So it's the same thing you saw before, but he puts a new font in here, all right, and then he gets this. Okay? The example itself looks a little contrived. It's like, why would you ever do something like that? That isn't even the point. It actually is a very good example, because it not only does it show you how to use a polygon, but it shows you how to use drawstring and write drawstring on an object. All right. Repaint, I already mentioned to you. Notice, as mentioned previously, you do not call paint. It's automatically called. Sometimes you might want to force the application to call the paint method. You do this, again, by saying repaint. The repaint method, as it says, clears the surface and then calls paint. The reason that it's not used that often is, even though you can do that, there's absolutely nothing wrong with doing it. Nothing. But just because you call repaint, you have no guarantee that it's immediately going to call paint for you. All right? It's supposed to call it as soon as it gets a free second or so. All right? All right. Says each of the preceding examples use the entire applet window for drawing. Sometimes you might want to confine your drawing to a space, such as a panel. So if you look, this is the example that they show here. they come in here, and this is something you should be able to do by now. So notice that what we have over here is we've got what? We've got our, if we set this thing up as a what was it, a border layout, the one with the north, south, east, west. We've got east here, and we've got center, right? And inside of here, we put in a bunch of check boxes. Okay, and if we click the rectangle, for example, we can put in a rectangle. So if we click all of them, okay, but the difference is now, instead of using the entire screen, we've just designated part of an area to do that. All right. All right. Handling mouse events. Okay, so again, if you're following along in the book, I'm on 957. Java allows you to create listener classes for mouse events. Mouse up, mouse down, mouse over, mouse out, etc. You can do any of those. All right. You've all seen things like rollovers where you take your mouse and you put it on an image and the image changes, and you pull the mouse out and it changes back to what it was originally. A lot of times you use reverse video. So if you've got a white image on a black background, when you put your mouse on it, it becomes a black image on a white background type of thing. All right? And this is one way that you can do it. I will tell you right now, in some ways at least, if you follow what Gaddis recommends here, and I recommend you do, but if you follow Gaddis's recommendation, this is sort of a pain in the butt. This is another one of those examples that, look, these are your different mouse events. Mouse pressed, mouse clicked, mouse released, mouse entered, and mouse exited. So let's pretend for just a second you wanted to just put in this one. You wanted a mouse entered. This is the only place you wanted to put in code, was right there. You still have to include all of the other ones. And you'll put it in, like here you'll say public void, mouse pressed, mouse event E, then right after that you'll have an open curly brace and a closed curly brace. So even though you're not going to put any code in there, all right, since you're implementing the mouse listener says you need all of these methods. Okay? And they'll show you an example of that in just a minute. How about here? So if we look in here at the example, here's one of those inner classes. So notice, we're writing something here for mouse pressed and mouse clicked, and we're writing something for mouse released and mouse entered and mouse exited. That's not usually the way you do things. Usually it's just one or maybe a couple of them that you put things in. So what is the author doing here? If you run this program and you take your mouse and you drag it around the screen, it'll tell you exactly where you are on the screen with the X and the Y coordinate. If you click the mouse clicked event will kick in. If you let go, then the released will click in. If you take your mouse and you put it into this area, the entered event will take place. If you hold down, the pressed event. If you hold down and drag, the dragged event will take place. So it is an example that shows you all of these things. All right? Although many of them you wouldn't use. So they've got a few more. Here's an example. It says this applet demonstrates how mouse events and mouse motion events can be handled. It lets the user draw boxes by dragging the mouse. So literally, if you run this program and you hold down on the mouse, I could have drawn this. Then if I let go, boom, it's drawn. If I click over here, hold down and draw again, I'd be drawing another square or rectangle over here. And I can fill up the whole screen with rectangles if I want to do that. So again, here's an example. Notice there's something in the mouse pressed event, and notice this. Still have to do the stuff we did before. All right, private class, my mouse listener, we have to implement mouse listener. So we have to register that mouse listener here like we did previously. But notice what's in here. All right, we're putting code in the mouse pressed event. We're putting no code in the mouse clicked event. We're putting no code in the mouse released event. We're putting no code in the mouse entered event. And no code in the mouse exited event. But we still have to put those in there. Since we're implementing the interface, that's the agreement that we're making with Java, that we will have those particular methods in there, even if we're not adding any code to them. All right, they've got a couple iterations of this mouse drawing program. All right, jump over into Timer. This is good because we'll finish this, then we'll take a break, and after the break we'll talk a little bit about that program. All right, so there's Timer, there's Audio, and that's it. So there's only about half a dozen or so pages left. A timer event is what you think it is, okay? As it says, it will regularly generate action events at programmer specified intervals. It used to be, if you remember this, that there were a lot of packages, you know, even older versions of Windows and the like. There were a lot of packages that if you didn't have any activity on the package for 15 minutes, it would time out. It might lock you out, it might stop, it might do anything. And the way they did that was they used a timer. All right. Now, for example, typically what happens, and you can change this by going into your global configurations, but I believe it's every 5 or every 10 minutes, for example, Word automatically saves for you. It's done with a timer. I'm not saying it's done with a Java timer, but that's the kind of thing that you use timers for, usually. So as mentioned, a timer object regularly generates action events at predefined times. And here's things that you can set up with it. All right. Notice you add the action listener, okay? And you can play with delays. You can check and see if the timer is running. You can set delays in your timer. You can tell the timer to begin. You can tell the timer to end. Oh, okay, I was wondering which one they did in here. This is where they're trying to simulate a ball bouncing on the screen. So they just make a little red circle and have it, you know, basically go up and down on the screen. So as it says, it uses the timer object to animate a bouncing ball. This is one if after the break, if we go over or when we go over the program for the thermometer and you look at it, you don't understand what a lot of those things mean. All right, basically I took it from the kind of the stuff that was in here. And this is explained much better. There's comments for everything that's in here, etc. So you draw a filled oval, and then what you're saying is you want to simulate this going up and down. So one thing we could do is we could basically have it go in a downward trend, and we could give it the speed we wanted it to, and when it reaches a certain, we could time it and see how long it took for it to reach the bottom of the screen. All right, once it reached there, we could tell it to go back up for a certain amount of time. And once it reached there, we could tell it to go back down again. I've seen all sorts of programs like this where they'll ask you, you know, they'll just show a ball going up and down. Then they'll say, should we bring more balls? Pretty soon you've got a screen, and literally the screen's got so many balls on it they can't really bounce because there's so many of them on the screen. All right, so a lot of times when they do this, they'll say, how about 1 ball? How about 2? How about 3? How about 10? Pretty soon you've got 100 balls on the screen, and you've got enough room really for about 50. So it's just, you see these things, but they're moving like this. It looks very staggered, so to speak. But it's a pretty good program for that reason. Finally, playing audio. So again, this is section 14.8, so it's page 971 in your book. As the author says, sounds that have been stored in an audio file may be played from a Java program. And this book is a little old, so it supports, there are newer files than this. Notice, like, for instance, well, WAV is in there, but there are other ones that are not even listed in there. MP3, not MP4, but MP3 is a sound file, for example. All right. And the program that they have in here, it's a real simple program if it's the one I think it is. Yes, it is. If you run it, it looks very small, but what it does, what was that, Armstrong, who said it's one small step for man, one giant step for mankind? So if you click play, it'll play that once. If you click loop, it'll play it, and then it'll go right back to the beginning and play it again. And if you loop it, after a while you'll get sick of it, so there's a stop button. Okay? So it's really, like I said, there's not a whole heck of a lot to it. Much of the stuff that they talk about in here is, I'm not going to say that this is never done, but even writing applets, I don't think, this is me, I could be totally wrong on this, but I don't think I am. All right, when I go in and try to look at some of the source code for applets, if I download one or if I'm running one, they're more often written in JavaScript than they are in Java. Because JavaScript now has got so much power that you can write things, have things run on both the client and the server. All right, So I'm not saying that they're never used, and I'm not saying that applets are never used, but I don't think they're as in favor as they used to be. Java is used much more as an application programming language than it is as an applet programming language. All right, and I'm not the only one who thinks that. So does Gaddis, because otherwise he wouldn't have written a 16-chapter book where only one chapter he does this. All right. So again, after the break, in just a couple minutes, literally in a minute or so, but after the break, we're going to look at, and I've got hard copies for you. We're going to look at, your assignment will be the house applet, which is here, and we're going to look at this thermometer applet. So let's take a break. It's 1:47. Tell you what, I'm going to produce this right away so I don't have to worry about it tonight. So let's come back at 2:05, but we'll still be done by around 2:30, if not earlier.